All right, so let's go ahead and finish this up, and then we're going to get into the really fun part of 4.2, okay? Application problems. So this one is just sort of a weird problem. X to the 2/3. Now my variable is on the main floor, but it has that weird fraction exponent. So first thing we've got to do is write it without that fractional exponent to see what we need to do, right? Now notice that we have a cube root. Now we're going to be doing this a lot in this section and in this chapter, and that is to get rid of these roots. So the way that you get rid of the cube root is you just cube it. So you're going to cube the left-hand side, which gets rid of the cube root. Whatever you do to one side, you got to do the other. So when we do that, all I have left on the left-hand side is x squared. On the right-hand side, I have whatever 25 to the third power is, a big number. And now, how do I get rid of a square? I'm going to take the square root. So square roots and squareds undo each other. Cube roots and cubes undo each other. Anyway, so I'll take the square root of that big old number, and I get x is 125. Remember, when you have a square, you're going to have two solutions. So one will be plus and one will be minus. So this is just a little trick. So you're going to need to know how to do this trick, how to get rid of this guy, right? Okay, so now let's get to application problems. Now these are actual problems that you may, at some point in your life, use, because it has to do with money. So we're going to talk about compound interest and eventually talk about continuous interest. So compound interest, we have this formula called I'm stealing it from Miss Roberts. We're going to call it the dirty formula because we have a clean formula. It's very has a lot in it. So let me explain what each thing is, okay? So the big A is your amount at the end. So it's once you put the money in, you leave it for 20 years, it's what's at the end, okay? Or it could be the amount that you owe at the end. You borrow money for a house. How much did you really pay at the very end for that house? You would be amazed. But anyway, okay. The P, if A is the amount at the end, the P is the amount at the beginning. It's often, instead of saying amount at the beginning, we just say principal. Okay. The R, of course, is your rate. The key is you have to write it without a percent. So you've got to change it from percent to a decimal before you put it into your formula. Your time must be in years. Okay, so if they give you months, you're going to divide by 12, right? So months, you're going to divide by 12. If they gave you days, you divide by 365, all that kind of stuff. Okay. Anyway, and the N is the number of times that you are going to compound your money in a year. Okay, so if I give you $1, then and you compound it twice a year, that means in 6 months you're going to get some interest on that dollar. And then starting in July, you're making interest on top of your interest. So compounding means making interest on the interest you've already made, right? So you want it to compound a lot. So, but if you compound it annually is just once a year. Biannually or semi-annually, you can think of semi-annual sales. Those are just twice. Quarterly, 4 quarters in a dollar. So there's 4 quarters in a year, 12 in a month, 365 for daily, unless they mention banker's daily. Banker's daily is 360. I guess a banker came up with that. So anyway, if I say daily, just assume that it is your regular normal daily, but occasionally they might mention banker's daily. Okay, so let's just work a problem. Suppose I have $2,500. I'm going to put it in an account, and it's paying 3% interest per year, compounded semi-annually. The minute you see compounded semi-annually, you go ahead and just write that formula down. Okay, so compounded, and if they use any of these words, you're going to just go straight and write that down. So you know the formula. All right. And then the next thing I do is I always just write out all my letters, the A's, the P's, the R's, the N's, the T's. I mean, literally, I see compounded whatever, and I write it down and write those letters. Then I go back and go in and read the problem. So when I read the problem, I'm um, I am depositing $2,500. So that is what I'm starting with. So that's my principal. Um, Deposited in account paying 3%. So I put my rate in. Now notice what I did. I changed the 3% to 0.03. You've got to take that decimal and move it 2 places to the left and get rid of your percent. And then it's compounded semi-annually. So semi-annually is twice a year. And they said, let's see, A says find the amount after 10 years. So I don't know what the amount is. So now I'm just going to go and plug everything into my formula. Just putting it in the right place. Notice that the N is in 2 places. Okay, that's in 2 places. That always helps me with formulas. Anyway, so I'm going to simplify it just a little bit. I simplified just this portion, 0.03 divided by 2. And I also simplified this portion. I'm going to simplify one more time, and then let's plug it in our calculator. Okay, so I'm going to put 2,500. I'm going to times 1.015, and then use the little caret that's under the clear button. Raise it to the 20th. And it's money. So I'm going to go ahead and round it up because it's 0.13 cents, but it's 13.75. So I'm going to go ahead and round it up. So you just have to be able to plug that into your calculator. Okay. Now they want to know how much interest was earned over that period. So this, again, remember, this is the amount that you had to pay 10 years later, right? You started with this much. So to figure out how much interest, or I guess it's interest, that you earned, not that you had to pay. Oops, sorry. So I need to take those two and just subtract them, right? So, so I'll subtract those, and so I earned 800. Yeah, I earned $867.14 in 10 years. All right. So Brendan has to pay a lump sum of $15,000 a year. What amount is deposited today at 2.4% compounded annually? Once again, the minute I see compounded annually, I write all that stuff down. Okay. Then I'm going to go back in and read it again and start filling it in. All right. So there's my, I have to pay this much. Okay. At the end in 8 years. So I put in the $15,000 in my 8 years. What amount deposited today? That's my principal. That's what I don't know. At 2.4%, I changed that to a decimal because that's what goes into my formula. And notice it's compounded annually, so that's just one time. So I'm going to take all those and plug it into my equation. Notice what I'm missing is my P. Okay, so what I want to do is get this as simplified as I can. Okay, so let's just start simplifying. Here we go. So I went ahead and simplified what was inside the parentheses. Now notice that this is just 1.024 raised to the 8th power. That's just a number, like a decimal. So if I had, let's say, $15,000 and I want to divide it by 2p, or let's say 2.1p, you're going to divide each side by that. All right, so that's all we're going to do. We're going to divide each side by 1.024 to the 8th power. Notice I didn't round it. Okay, I didn't plug it in my calculator and round it. I want my calculator to do all this work for me. Okay, because otherwise you get a lot of rounding errors. So Anyway, so that's what we're going to do. We're going to eventually, if I can do that. Yeah. So I plugged that into my calculator. Once again, I just put $15,000, divide it by, put in parentheses that, and I raise it to the eighth power. It is going to raise to the eighth power first because you do exponents before division. Okay, so your calculator will know to do that. So that's $12,407.71. Okay, now here's the problem. I'm supposed to have this much money right now. Remember, that's what they were asking. They were saying, why do I have to put in now to have $15,000 in 8 years? So you have to have that now. Well, what if you don't have that now? You got close, but I don't have it. So that I'm going to want to deposit this is available to deposit now. What interest rate do I need for the money to increase to this? In other words, I realize I'm not going to have the money I need in 8 years. I need to find another bank and find a better interest rate. So once again, we are compounding annually. So I'm going to just write down my formula, write down all my letters. Notice that I have changed what I have, right? I still know that I need this $15,000. Still know it's 8 years, but this is what I'm changing. And now I know what I'm going to enter. So I'm trying to solve for the rate. That's where it gets a little wonky. Okay, so let's plug that in my calculator. Notice where my letter is. Right, whoops, there it is. It's sort of nestled in amongst everything else, okay? So, what do we do? Well, first thing I'm going to do is get rid of that fraction, r over 1, so it's just 1 plus r, okay? Raised to the eighth power. Now, I need to get this guy all by itself. So that means I need to move this, the 12,025 over to this side. Now notice I'm not going to do it by adding and subtracting because this is multiplied together. So I'm going to divide both sides by 12,025. And when I do that, I wind up with just that 15,000 over 12,025. Notice I leave it. I don't put it in my calculator and then round. Don't want to round if at all possible. Now I have 1 plus r to the eighth power. How do I get rid of the eighth power? Same way that I got rid of when it was x squared. I would take the square root. When it is x to the third, I would take the cube root. So when it's x to the eighth, what do? I'm going to take the eighth root. Yes, it's weird, but so look what I'm going to get. On the right-hand side, I have just 1 plus r. On the left-hand side, I have the eighth root of the 15,000 over 12,025. All right, so to get r by itself, I need to get my 1 to the other side. Well, I do it just like I've always been doing since Algebra 1. I subtract 1 from that. So I'm going to put all of this in my calculator. Okay, so let's do it. The eighth root. How do we get the eighth root? So notice we do not have an eighth root on their screen. So it's under math. So if you go to math, do you see the fifth one down says n and has that little square root symbol? Okay, so we're going to do the fifth one down and put the 8 in there and then come in and put, I don't know if this calculator will do it. You might have to put parentheses. Depends on your calculator. Some calculators mess up. So I'm going to go ahead and put the parentheses. It won't hurt me. Okay. Now I need to say -1, but notice what happens if I just put -1 in there. See how I put it underneath the square or the eighth root? So I need to get rid of that. I need to hit my right arrow button. That gets me out from under my eighth root. And now that's what I meant to plug in, right? So 0.028, and it keeps going. But so my so I got 0.028, and I need to change that to a decimal. So I call it Dr. Pepper. Dr. Pepper. Okay, so if I want to have a percent sign, I'm going to take my decimal, move it here, and add my percent sign. If I want to get rid of my percent sign, I get rid of it and move my decimal 2 places to the left. So I call that Dr. Pepper. Anyway, so that's what I did. I want to have percent, so I move it 2 places and I add a percent at the end. All right, so that's my answer, 2.8%. Okay, now, if you've noticed, it depends on what banks you go to, but a lot of banks compound continuously. They don't do it annually or biannually. They are always compounding your money. So this is basically to develop this letter E. This is how we figure out the letter E. Notice I have $1. $1. I've invested it at 100% interest, compounded n times a year, and I'm going to plug it into this formula. Okay, and I just keep increasing how many times I compound it. So it seems like I would keep going, and the more you compound it, the more money you're going to make, and all you need is $1. But if you get it compounding all the time, you're going to make a ton of money. But that's not really what happens. If I compound it one time, then I'll have $2 at the end of the year. If I compound it two times, I'll have $2.23. So it is going up a lot. But notice it's sort of levels off. Okay, it looks like it's getting close to one number, 2.718 something something something, and that is the value of E. Okay, you use E so much, it's like pi in geometry. It happens so much in finance that it's not a variable. It actually is a number. Okay, all right. So now let's use it. Okay, let me go ahead and get rid of that again. All right. Okay, so this is our clean formula. We have the dirty formula. Doesn't that look much cleaner? This is when the A's and P's are still the same and the R's and T's are still the same. So we are going to use this whenever it says it is compounded continuously. Continuously. So the minute it says compounded continuously, you put the PERT formula. Call it the clean formula, because there is such a thing as PERT shampoo. If you're young, you probably have never heard of it. Just you'll see it in Walmart. That's all the old people like me are buying the PERT. Anyway, so the A is still the same thing. A is what you want at the end. P is what you've deposited at the beginning. The R is your rate. The time is your T. So we're going to deposit $8,000. So that's going to be my P value at 5%. And we're going to do that continuously for 6 years. So I went ahead and filled in my blanks. And I am going to just plug that into my formula. Notice that I've changed my 5% to 0.05 before I plug it in. So I plug that in, and let's put it in our calculator. So we're going to have 8,000. Now E, where is the E? Okay, it is not really on the face unless you're looking at the little bitty ones. So do you see right here the LN? Let's see if I can, if they don't know, it won't let me circle it. Anyway, look on the left. You'll see a thing that says log, and underneath is LN. Well, right above LN is E to the X, and it's really tiny. So that's what we're going to use. We're going to do the second and LN, and that it already puts the E and puts your cursor at the top. So you don't have to hit the caret button. And then 0.05 times 6. So that's going to give me over $10,000, right? So that's my answer, $10,798,087. All right. So now we are just going to compare the interest earned as we compound more frequently. Okay. So this is really, it's going to tell us some good information, but this is what I want you to use to check and make sure that you are using your calculator correctly. So I have 2,000 500 that I'm investing. So that's going to be my P. We found the total amount after 10 years. It was in an account paying 3%. So I'm changing my 3%. And it's going to change. It's going to compound quarterly. That's what they ask. Monthly, daily, continuously. So I'm doing it all. I'm going to say annually, semi-annually, quarterly, monthly, daily, continuously, and see what happens. So for these guys, I'm going to use my dirty formula. Okay. But for the continuous one, I use my PERT formula. So I went ahead and plugged it into the formulas and worked it out. So what I want you guys to do, and you can do it right now by pausing, um, or you can do it later, but I want to make sure that once you have this part correct, that you get the right answer. Okay. Usually in a class of 20 people or so, I will have 5 students that don't practice this and they miss it on the test. And I really care what your answer is. This is money. We're talking money now. So we don't want to mess up with money, right? Anyway, so I'm just notice with the annually and semi-annually and quarterly, all of these, the only thing that I am changing is that number, is my N value. Everything else stays the same. So again, when you plug this into your calculator, I'll do the second one. When I plug it into the calculator, I'm going to put 0.03 divided by 2, and my calculator knows to do the division first. And then I'm going to raise that one, to the 20th, because I did the second. Yeah, I'm doing the second one. So I have that one. When you are practicing, I want you a few times at least to plug it in like I just did. Don't just always say second and enter and go back and change things, okay? Because when you do that, you may not know how to enter it in your calculator, okay? So anyway, my suggestion is to plug all of these guys in and then try it, okay? Plug this in and make sure that you are getting these correct answers, okay? The other thing I want you to notice is, yes, as you compound it, you're making more and more and more, but it's just, at first you're making a fair amount more, but by the end, from going to compound it 365 times in a year to always compounding it only went up by 4 cents. I mean, 4 cents is great, but it doesn't buy a whole lot. So going from daily to continuously is not a humongous jump in how much money you're going to make. Okay, now let's do for reals. Okay, this is a real. I did not make this up. Okay, so my daughter, my second daughter, was 19 years old, and she came to SEC, and no, actually she went to SMC, and she decided school was not for her, so she came and lived with us and worked at a plant. She was making $30,000 a year. She was bending metal. She was a sheet metal operator. So since she wasn't really having to pay rent or car payments or whatever, we said, make sure you put some money, at least half of it, in the stock market because you're making money. So she did. So she put $15,000 in the stock market 1 year. Actually, I think she did it 2 years. But anyway, but let's say this is the only year that she put money into retirement. This is it. And it averages about 10% interest rate. Now, that sounds like a high thing compared to what a bank pays, but a lot of stocks do that. We've had her put it in QQQ, and because it was earning 10% over the past 20 years. So let's figure out how much money she's going to have when she retires at 59. If she retires at 59, if it's compounded continuously. Okay. Notice she started at 49 and so she'll be drawing it out, 40 years later? So that's 40 years later. So notice it says compounded continuously. So the minute I see continuously, I do PERT and I write my A's and P's and R's and T's. How much money did we put in? Do you remember? 15,000. So it's 15,000 at 10%, for 40 years. Let's see how much money she's going to have when she's 59. I'm going to just plug it in. I have it over there, but I want you to see that this is for reals, y'all. This is for reals. How much do you guess? How much do you think it's going to be? It's $15,000. Maybe 30,000? Might double by then. Do you see where that decimal is? Y'all see where that is? We're talking almost $1 million, y'all. 818,975,025 for putting 15,000 in and leaving it. She's just not pulling it out for anything. That's just 1 year, y'all. If she does this multiple times, she's going to be a millionaire when she retires, all from what she put in as a 19-year-old. Okay. Let's say, but we don't all have $15,000. We don't have $15,000 just laying around, but you might be able to invest 1,000. Now you may not have 1,000 laying around, but that's less than 100 a month. So you start scrounging in your seat cushions, okay, and start looking for some money, because you just wait. You got $1,000. You're putting in the stock market at the same thing in QQQ. It's getting 10% just this year. How much are you going to have in 40 years if you invested it today? It's in my pert. $54,000, y'all. I wish I was teaching this to you. I want to see your eyes. If they aren't bugging out of your head, you're not paying attention. You need to rewind and go back and listen to what I just said. If you put $1,000 in the stock market, and let's hope the stock market does well, but you put $1,000 in the stock market this year, it will turn into $54,000. And then if you do it next year, that's another $54,000. And the next year, 1,000 turns into $54,000. That's crazy. That's crazy. That is exponential growth, because the money does like this. I really just want to see your face. Maybe I should do this in class so I can see y'all's face. It goes like this. All right. So, you know what? I want to see y'all's faces. I'm going to tell y'all this later. But just know it grows a lot. It really grows a lot. Okay. This is my kit's free tip. I'm just telling you right now, this is going to be extra credit. This is extra credit on your test. If you know how to use the rule of 72, you're going to get some points on your test. Okay. So this is basically a shortcut method for doing this. Okay. It's not as accurate. Okay. It's not going to get you down to the penny. Okay. But it's pretty darn close. So what you do is you take 72 and you divide it by whatever the interest rate is. Okay. So if we are again, let's just put money in the stock market that's earning 10%. That means in 7.2 years, your money will double. Okay. It will double. So let's just say 7 years. Okay. 7 years. So if you are 20 years old and you put $1,000 in right now, that means when you are 27, it will be 2,000. It will double. 7 years later, it will double again, 4,000. 7 years later, it will double again, 8,000. 7 years later, 16,000. 7 years later, 32,000. Can you retire when you're 55 years old? Because that's how much you would have, right? They're asking if I can retire at 60. So let me do this. 62. 64,000. Could I retire then? Well, if that's the only money you have, no. But that's all you've put in. That's all you put in. You put in $1,000. That's it. When you're 62, you would have $64,000. But you could keep going. 69. When you're 69, you'd have 128,000. When you're 72, you got $250,000. When you're 83, you've got $500,000. Now, what I want you to notice, and this is huge. How much did you gain in these 7 years? Just $1,000. I mean, that's good. But look at this 7 years. This is the same amount of time, y'all. You went from $250,000 to $500,000. You gained $500,000 in just 7 years. And here's the other thing. In 7 more years, how much is this person gonna have? $1,000,000. 1 point, what's that, 24? Okay. 7 more years? Whoops. Yeah, 97. You would have 2.48 million. All right. So think about Elon Musk. I don't know how much money he has. He's got a ton. If it's invested, he's like, in 7 years, he's going to have double what he has now. So I'm telling you all of this because this is what counts. How early you invest. And most of y'all are younger than me, so I'm trying to tell you this because I didn't invest when I was 20. When I was 20, I was still in school. I didn't scrounge up money and try and invest it in the stock market. Okay. I didn't invest till later in life. But if you invest early, it starts this process early. You know, let me keep in mind now, yeah, this is when you are 20 years old. But if you take that $1,000, that's all that's been invested. Now you have to wait till you're 97, but that $1,000 is almost $2.5 million from from investing 1,000. That is just, it's crazy. It's crazy how many works. Um, I've got to do it. I'm just going to do it now. Just maybe you can video yourself reacting to what I'm saying. Okay, so here you are. Here you are at 20. You broke. Here you are at 30. Guess what? Still broke. Here you are at 40. Guess what? Still pretty broke. But you can see, oh, I think I, I might, I might be able to afford Chick-fil-A. Okay, by the time you're 50, you're like, okay, I can go to Outback now. Do you see how quickly it goes up? From 50 to to 80? I mean, your money goes up tremendously. Okay? What if you could shift all of this? Oh, wait, I can do this because I think, what if I could take, oh, it's going to pick up the red too. Anyway, but you get it. What if I could shift, I can't do it. Anyway, if I could shift this blue, I'll do it in a different color. If I could shift this blue so that it is like this over here and it goes up here, then that means when I'm 50, oh, I'm in the money. Okay. The way you shift it is you start investing early. Okay. I remember my grandmother-in-law, she was about 83. She looked at her bank account and went, oh my gosh, I'm rich. And she went out and bought her a gold bracelet. She didn't realize how much money she had because she hadn't really paid attention to all of this going on because she was just still living off what she normally lived off of. Anyway, all right. So here's one other thing to notice that is free of charge. You can tip me if you want to. Anyway, look at the percentages. So you need to invest early. Invest early. That's what I've told you. But this talks about aggressively, invest aggressively. If you put 10,000 in and you only have 1.5% interest, you're going to have $20,000 in 48 years. Okay. If it was at 6%, you're going to have $160,000 from that 10,000. Do you see how much it went up? And then if it was 12%, it's like $2.5 million. So you want to invest aggressively when you are young. Once you get old and you need that money, you don't want to invest aggressively because you can lose it. When you invest aggressively, you that means it's a higher risk. So you could lose the money, but when you're young, it usually bounces back because it usually does this. That's a stock market. It's going up and down, up and down. But over the long haul, it's going up. Okay. All right. Last thing. Um, and this may be on your test. Exponential models. This is definitely in my lab. So this is all exponential functions is about anything that grows fast. Okay. Anything that grows fast. So here's another example. Data from recent years indicate the future amounts of carbon dioxide in the atmosphere may grow according to the table. Notice it's little and it's slowly growing, and then all of a sudden, whoo, it's growing. That's exponential growth. All right. Anyway, estimate the atmospheric carbon dioxide levels in parts per million in 2025. All right. So notice that 2025 isn't on there. 2025 will be in here somewhere. Okay. So notice that this is about 75 years and this is 215. That's how much parts per million it's going to go up. So what we're going to do is we're going to find the slope. How much per year? So we're going to take 590 minus 375. I already did that out there. That was 215. Divide it by my 75 years. And that means in about every year, it is going up about 2.87 per year. Okay. Now, that's not exponential, but it gives us an idea. So if I take that and I times it by, now that notice that 225 is right in here. Okay. So if I take that, it's going to go up by it's going to go up by 2.87 for 25 years. So I'll multiply it by 25. So this is how much it should go up, right? So I'm just going to add that on. So that should say 2025. In 2025, we should have 446. And that makes sense, right? 446 point, that's in between those. If it wasn't, there would be a problem. Okay, one model for the data of that function is this. Notice it is exponential. It has the x in the exponents. Use the graph of the model to estimate when the carbon dioxide will be triple the level it was in 2000. Okay, so what we're going to do is we are going to put this in my graph, in my calculator, and then we want to find out when it's going to be triple what it was in 2000. Well, in 2000, it was 375. So let's multiply that by 3, and that is going to give me 1125. So I'm going to have two graphs. I'm going to put two graphs on my calculator. I'm going to put this one. So that is my exponential. And then I'm going to put this one. That's going to give me a line. And that's going to show me when, that will be my when, it's going to be at 1125. That's what they're asking, right? Is when the carbon dioxide is going to be that triple. All right, so let's put it in my calculator. Y equals, let's see. 0.001942 x, let's see, 0.00609x. All right, and then my y, 1125. Okay. Now, when I graph this thing, I'm having a hard time. When I hit, my window, when I graph it, there's a problem. Do you see the problem? Nothing's really showing up. Okay, that's because this guy here has barely started growing, so it looks like 0, and this guy here is way up here. So I know my Y value has to be way higher. Okay, so I've already done a few guessing and plugging in. So I'm going to change it. Notice I've set the window. Go back. Set the window to 4,000 for the X and 2,000 for the Y. So let me go back in there and do my window, 4,000 for my X. Let's go up here, clear, 4,000, and I'm going to go up maybe by 500, I don't know. And then, was that that's my X. My Y needed to be 2,000. And again, I didn't do anything magical to do this. I plugged it in just like we just did, and I was like, oh, it's got to be bigger. And so I started just guessing. And then I couldn't see it all, so I just kept guessing. Okay, so here we go. So they want to know when that intersection happens. So intersection, remember, anytime you want to find out what is happening on that graph, you do second and trace. I want to find out where that intersection is.
Looking for a fast digging, expectation lifting game changer? The Bobcat E88 compact excavator puts strength on your side with its class leading lift capability, smooth, responsive hydraulic controls, and a high performance turbo diesel engine that requires no regeneration for simpler maintenance. Stop into your local Bobcat dealer to see why the E88 is one of the highest performing excavators in its size class. Bobcat.
Okay. Do any of y'all need a Bobcat? Anyway, okay, we're going to do the left bound, and I don't even know where I am. Where am I? Okay, look down there. See, it says X is negative something. See right? Oh, I can move it. Oh, that's nice. Okay, so this is my left bound. And enter. And my right bound. So there's my intersection. 2187. Notice my Y value is really close to 1125. It's not exact, but it's really close. So this is going to happen in the year 2187 and a half. So it's in the year 2187 that's going to happen. Let's see. Yep. 21. Did I say 87? I said 87? I don't know why I put 70. Yeah, it should be 87. Sorry about that. Anyway, so that should be 87 in the year 2187. All right. So what I want y'all to do is to make sure you have watched this video. This rule of 72 is your extra credit for your test. But all the rest of this is going to be on your test. We're going to talk about this a lot. You're going to have a lot of these type questions on your test. So I enjoyed teaching y'all, but I much prefer seeing your faces when I do it.